we found 10 million secrets last year, just last year. 10 million secrets in public repositories on GitHub.
What you're referring to is more like, well, all the commits you've done so far, I can still, as a public person, click on this link and see what you've done in the past, all the way to the very first day you started working on it.
Yeah, exactly.
If you upload that.
And so there's lots of ways that secrets kind of get leaked too. So GitHub has a public API. Anyone can view it. You don't need authentication. There's a public ledger of every single repository and everything that's happening.
I just want to say thank you for all the love you showed Shilpi and I at KubeCon in Amsterdam, as well as RSA in San Francisco over the past couple of weeks. I cannot be grateful enough that showing so much love to us. You've supported us to grow on social media and on Spotify and all these podcast platforms. So thank you so much for all the love and support you showed us. Thank you so much for coming and taking selfies with us. And some of you were grateful enough to come on my daily vlog, which I post on LinkedIn and Twitter. Thank you so much for being part of our life and making it what it is today. All right, let's get to the episode before I get emotional. Have you ever wondered, are there more secrets than simple username password? In a world of cloud, APIs, microservices, and everything else that comes with machine-to-machine communication, we have developed a lot more kinds of secrets that float around. Whether it's AWS Access Keys or whether it's your API access token, there's a lot more information that floats around on the internet as secrets. In this episode, we had Mackenzie Jackson from GitGuardian. They recently released a report after scanning all the public repositories on GitHub, how many repositories had secrets just lying around. I'm not talking name passwords or AWS Access Keys, a lot more different kind. So in this conversation, we spoke about what are the kind of secrets, what can you do about finding secrets, why sometimes the only option you have is just to recycle the keys instead of just trying to go and removing them. Hey, let's be honest, if a key is on the internet, it's just on the internet. You never know how many copies have been made of it, so you're better off just recycling the keys in the first place. And as easy as it sounds when I say it, it's a lot more difficult. So when you're developing some keys, make sure you have a recycle process that you're evolving as well. In case of a compromise, you can recycle those keys. Even if you just do that, at least you're in a much better state than a lot more people. They found a lot more in the report, so Mackenzie and I went into the details of what are secrets, what kind of secrets are they seeing more publicly used. GitGuardian is a very popular open source project that you can participate in. The number of stars in the GitHub repo would be a good enough proof that, hey, it's a popular software, which is used by a lot of people, and it's a free one as well. So definitely check that out. It's an open source software, which you can use to find out secrets in your repository, public and private, I think. I've been using the open source version a couple of times, and I think it's been very valuable, at least for me to identify I had access keys in my GitHub history, which I had to delete. So please don't look into my GitHub history for my GitHub repository, but I have made sure that those keys don't work anymore. So it was really valuable. I hope you find this episode valuable. Mackenzie Jackson. And if you know someone who's trying to work on a secret management strategy or thinking about doing secret management in the organization, definitely share this episode with them. And if you're here for the second or third time, I really appreciate if you can leave us a review on iTunes or subscribe or follow on Spotify, Google Podcasts, like audio platforms, or video platforms like YouTube and LinkedIn, where, by the way, we're about to hit 10K or maybe 20K, depending on how quickly this kind of spreads. We are looking at getting the 10K mark in YouTube very soon. So I would really appreciate if you can help us cross across that. And if you have any questions, feel free to reach out as well, because we talk about cloud security all day, every day. I hope you enjoyed this episode with Mackenzie Jackson, and I will see you in the next episode. Peace.
Welcome to Cloud Security Podcast. This is a virtual coffee edition with Mackenzie. And for people who don't know who you are, what's your name and what are you doing in cybersecurity, man?
Yeah, I think a lot of people probably don't know who I am. Yeah, I'm Mackenzie Jackson. So we're here in the Netherlands at KubeCon. I work for a company called GitGuardian. Yep. We're a code security platform. And yeah, we're all about code security. My role is a developer and security advocate, really sharing the good word of how to build more secure applications.
Interesting. And talking about applications and secrets together, because a lot of our audience is developer first, security first. We have a good mix of it as well. What are secrets actually? Let me start there first. Yeah. Just level the playing field. What are secrets for people who don't think it's just, at least I think it's just passwords. Are they just passwords?
Well, yeah. I mean, the technical term for it is digital authentication credentials.
Yeah.
Right. So they're typically passwords, but they're passwords that are mostly made to be used by other machines. So machine-to-machine identity. Now, password peers, for an FTP server or a database are still secrets.
Yeah.
The majority of secrets, though, are things like API keys, security certificates, encryption keys. And these are all used not by humans, but by other machines. And how we've ended up with so many secrets is that we've moved away from an architecture of the monolith, like the giant software written in COBOL that, like is millions of lines long. We're have an architecture of microsystems, microservices.
Microservices,
It's SaaS platforms, everything's interconnected. It makes it much more scalable. It makes it faster to develop. We can focus on what we're doing. We can palm off authentication to Okta and search to Algolia. But it means we need to authenticate. That's why we end up with so many of these secrets.
Okay. Cool. To your point then, because we moved on from monolithic architecture to microservices and have more access keys, access tokens, API keys, AWS access keys, multi-cloud. So how are we dealing with this right now? Because clearly it's been going on for some time. It's like identity access management where identity in my mind was solved, but then you found, oh wait, cloud identity is different. That's the same case here as well, where it's not just as simple as I've got a password manager.
So, and this is kind of some of the challenges of it is that you have these systems called secrets managers, which manage secrets, funnily enough. And the idea behind it is that you want to have all your secrets centralized, wrapped in lots of authentication layer with logs and everything. And once you have that component, then, you would think job done. But the problem is that all your developers, all your team leads, different engineers, your DevOps team need access to these secrets. The more tightly strapped down they are, the more likely it is that I'm going to create secrets.txt on my desktop file, right? And let's talk about the scenario of you're a developer and I say, hey, build me this feature. I need you to connect to this database. And I just, So the first thing you do is you just hard code those credentials in because all you want to do is just quickly test it.
That's pretty much it.
Get it done. And then later on, you remove them, you use environment variables, you do it properly, right?
Of course.
But the problem is that in Git, your entire history is tracked. So when you go to code review, your passwords, your secrets are not there. The reviewer doesn't see them. But 100 commits ago, when you first started out, you hard coded the secrets. They're in your Git history. They've moved on from that secrets manager. Now they're backed up in your code backup systems. They may be copied onto messaging systems. They may be in your wikis, but ultimately you don't know. Because Git doesn't have intense logs of who's accessed what and where your code sprawled to. So now your secrets are sprawled, but you don't understand it. You still think they're in your secrets manager, but they're running around everywhere, causing all kinds of trouble.
And it's funny you mentioned secret sprawl because that was kind of one of the reasons why I kind of thought of you to talk about, because you guys came up with a report as well, like a secret sprawl report. I'm going to talk about the findings. I'll let you talk about the findings, but what are some of the highlights for you, considering you've been in the secret space for a long time?
So the state of secrets, this is the third year we've released it. And essentially it's come about because, at GitGuardian, we build these different services and systems. And as a result, we find a lot of secrets. So we decided that we would create some pro bono alerting. So when we find something, if we know who's leaked it, we'll message them. And then essentially what we do every year is we put in a report what we've found. So the highlight of the report is, basically that just in public repositories on GitHub. So there was, tens of millions of developers use GitHub. Last year, there was over 1 billion commits. So 1 billion contributions made publicly to GitHub.
Wow.
We scanned all of them.
Right. Okay.
Public ones. We've scanned all of them publicly. We found 10 million secrets last year, just last year. 10 million secrets in public repositories on GitHub.
Wow. Because we've been working in the Git space for a long time. Like a lot of people have. And I would have thought the part you called out where, hey, make sure you don't put your secrets in, but it's already in Git history somewhere. Is that true that you can't take it out?
Well, not easily. The main thing is that you don't know they're there. Right? So they're in your history. You don't really know they're there. Can you rewrite your history? Yes. If you're in a team like a team of multiple people, rewriting your history is totally a pain because if your history is different to my history, it throws an error. So to be able to do that is, but also once it's in Git, if it goes to your remote repository, you don't know where it's ended up, what machines it's on, so even if you got rid of it, it's still compromised.
Actually, I think that's a good point as well, because the clear delineation over here, a lot of people would look at GitHub and go, well, my current master branch doesn't have any secrets. But what you're referring to is more like, well, all the commits you've done so far, I can still, as a public person, click on this link and see what you've done in the past, all the way to the very first day you started working on it.
Exactly.
If you upload that.
And so there's lots of ways that secrets kind of get leaked too. So GitHub has a public API. Anyone can view it. You don't need authentication. That's a public ledger of every single repository and everything that's happening live.
Yeah.
Very easy to scan. One of the most interesting events that you can scan for is what they call the public event. This is when a private repository is now made public. Remember that when you make a repository public, you're making all of its history public too. That's something that often contains secrets.
Yeah.
But there's also lots of other scenarios where secrets get leaked publicly. So you say, okay, you're not silly enough to ever hard code a secret and push it publicly. Okay, fair enough. I'll believe you.
Yeah.
But in the scenario where you're trying to debug something, so you create a debug log, that debug log might have your environment variables printed in it.
Yeah.
You git add all, like, just capture everything. Now that debug log is in your Git repository. There's all these types of
accidental
leakages that can happen as a result of just code. And it happens, this is a funny story. A friend of mine was telling me, he's a senior developer. He's one of the best developers that I know.
Yeah.
And like, if you asked him, should I hard code secrets? He would say no.
Yeah.
His wife was pregnant. He was working from home. His wife went into labor. He just thought, oh crap. He had just kind of been issued a key for an Amazon Web Services.
Right.
And then just wife's in labor, git add all, git push out the door. He came back from maternity leave 2 weeks later and realized that he had pushed publicly admin access keys for AWS.
Oh my God.
Now, like, nothing actually came of that. The team caught them and that, but still, this is like a scenario where a very experienced developer still makes it, and it just happens, right? I've done it. And I am like, I did it whilst making a video about why you shouldn't do it. I accidentally pushed the wrong keys to GitHub.
So you reckon if there are individuals who are listening to this, who maybe just individually working on it, may not be working on, I guess, like with as a team, it's still easy for them to read out their history. They can just delete that. But as a team, because I'm also thinking as a business, you have multiple business units.
Yeah.
It's not just like, and you're all feeding into one repository as well.
Yeah.
So that makes it even, so what do people do then? Because I think, I don't know what people would do at that point.
The only thing that you can do, this is the only thing that you can do if a secret gets into your Git repository, private or public or wherever, you've lost track of it. The secret now needs to be revoked.
Okay.
You need to issue a new secret, right? There's lots of people get a credential, strip back all of its permissions, leak it on GitHub, see how long it takes for someone to find it. It'll be less than a minute.
Less than a minute. We've
done this experiment lots of times, right?
I think it'll be funny. If anyone who's watching or listening, they should definitely try and put a fake key in it. And see.
Definitely.
Actually, because isn't there like a concept of honey token as well?
Yeah. So this year we actually created, honey tokens aren't a new concept, right? They've been around for a little bit, but this year we created a couple of projects around honey tokens. So there's an open source project called ggcanary. And that's a way that you can...
Is it like the Justin Bieber's wife, ggcanary?
I don't know. Are we going to get sued by Justin Bieber?
It's an open source project, Justin Bieber.
Bieber. Don't.
Yeah, no one owns it. We just make it for the community.
That will create, you need an AWS account, but it will create tokens with the correct amount of permissions.
Yep.
And then what will happen is they will trigger if someone tries to use them. And it will give you lots of information. So you can use that to leak them on GitHub.
Yeah.
But why these tokens exist is that one of the first things that a malicious actor does in any kind of breach is that immediately when they gain access to something, they want to persist access.
That's right. Yeah.
They want to move into different systems.
Right.
The easiest way to do that is with secrets.
Yeah.
So the first thing that they're going to do is enumerate all the data and just try and find low-hanging fruit secrets.
Yeah.
Like persist access. If you leave secrets intentionally that are honey tokens in lots of different places, then your alerting systems will light up like a Christmas tree if someone makes access, and you will know exactly where they are and you'll know that you have a breach.
Right.
And if you're worried about your source code getting leaked somewhere, then you can put them in your source code.
Yeah.
And if they ever get leaked and that source code is ever made public,
then
you'll also know about it.
Interesting. Oh, was there like a common set of secrets in the, 100 million repository that you kind of scanned?
Yeah.
Was there a common type of secret that was identified, which is like, hey, there's more API tokens versus more AWS Access tokens?
Yeah, so we have some interesting results. There's lots of different types of secrets. The number one most common type of secret is database credentials.
Okay. Like an RDS or something, like a database, actual, like, oh, wow.
Like username, password.
In the GitHub.
In the GitHub.
Wow.
But that's about 25% of what we found. 20% of what we found was for cloud infrastructure. So that's over 1 million. That's 2 million actually.
Yeah.
And we validate these.
Oh, right. So it's not just like you found, it's a secret.
So a lot of people kind of say like, okay, but like, how do you really know it's a secret? Because secrets are high entropy strings. They're random strings, right? But URLs, unique identifiers, all high entropy strings. So how can we be sure?
Yeah.
So we validate secrets. We have lots of post-validation. We check what they actually do before marking them as a positive. So 2 million cloud provider keys that were valid were leaked publicly on github.com. That's like huge, because even if they're just for you personally, I can still rack up a huge bill for you.
Yeah.
And then there's lots of other interesting, the full report will show you, we find them for messaging systems. Attackers love these because you can do internal phishing campaigns, post it from within your own Slack.
Yeah.
And about 1% or nearly 2% of the secrets that we found were hub access tokens. So your access token for your private repositories, you've just made public.
Wow. Oh, that's why you're talking about the public event that you were talking about.
Yeah.
Everything you've done so far has suddenly become public.
Yeah.
Wow. And is there like some sense of responsibility that GitHub or AWS or all these people should be taking over this as well? Because you almost feel like, and I don't want to say that, hey, it's all their responsibility, because I guess you can't know every scenario in the world. You're just providing a service. So like, are they doing something about it?
Actually, yes. And so there's the concept of the shared responsibility model.
Yeah.
And there are a few organizations that do this, particularly in the public space. Now, public is interesting to talk about because we throw out big numbers and wow, 10 million. The real threat is private. But just focusing on public, if you leak an AWS credential, AWS are actively looking for them, and they will quarantine them if they find them.
Right.
Which means that they will reduce their permissions. Someone else can't run up a huge bill or something like that. That's not without its risks, because you leak a real AWS key and if it gets quarantined, all of a sudden that key doesn't work. You could have just broken production.
That's right. Yeah.
So these things come with risks that as well. Now, there are some other providers that also look for their own secrets, but it's a lot to scan GitHub. There's a lot of information. It's a fire hose. And if you're looking for AWS is just looking for one type of key, they know, but we look for, nearly 400 different types of credentials on these places. We're scanning code 400 times with different detectors.
Wait, so, because you know how we've kind of started the conversation with developer first and talk about developers as well. One of the challenges, and we had a couple of conversations through KubeCon and RSA as well, where the conversation always revolves around the fact that you can make a security tool, but to have an adoption at the developer side is always challenging. And secrets is probably clearly, as you called out, if there are 100 million or even 1 million secrets out there, clearly someone somewhere, when they find out about it, it's like alarm bells going off. But if they do use open source software, the high tokens or whatever, do you feel people are ready to even respond to those kind of things?
This is a really interesting stat. To answer this, we have to kind of take a look away from public infrastructure and go into internal infrastructure.
Yeah.
So at GitGuardian, like the products that we sell, we scan internal infrastructure for secrets, right?
Right.
Let's move away from that quick.
Yeah.
But we also have stats on what we find in these companies when we scan them for secrets.
Right.
So typically when we first scan a company, on an average size company, let's say they have 400 developers, it's fairly small, but up there, right?
Yeah.
We'll find about 13,000 secrets in their repositories. 1,000 of those will be completely unique.
Yeah.
But if you're a security engineer, you don't know, you just see secrets. So you're seeing 13,000 secrets. 400 developers, you'll probably have 4 AppSec engineers, 1 per 100.
Yes.
So you do the math, there's about 3,500 secrets that each AppSec engineer has to deal with every year. So being aware of the problem is almost worse than just living in bliss of not that it exists. Because now you have to investigate each one, find out what the secrets does. You need to rotate it. You need to redeploy it. And you need to do all of that 3,500 times without causing a server to outage.
That's right. Yeah. And without pissing off people.
Without pissing off people as well.
Maybe not updating a LinkedIn profile after sorry, I should have done that.
So the harder thing is kind of remediating that.
Yeah.
And that's secrets detection is important because you need to know, but you need to know to be able to remediate it as well. But there are things, going back to individual developers, what can developers do is that this is from the security point of view, but developers can stop the bleeding.
Yeah.
And there's simple things that they can do, like creating a Git Hook, like a pre-commit Git Hook, which checks your commits before your remote repository accepts them for secrets.
Right.
Then if you've got something in a debug log that you didn't know about, then you're going to be aware of it and you can change it, and you don't need to rewrite your history because it hasn't entered the history yet. you can be proactive, and then that stops the bleeding.
Yeah.
So there are things like from the individual developer, that shift left mentality. There's lots of things that they can do.
Yeah.
But you also need it from the top. You need visibility over where these secrets are.
Yeah. And I think the reason I ask that is also because a lot of the conversation we have around cloud and cloud security, a lot of people are not even ready for incident response. Like this, that's why it's not spoken about.
Yeah.
Probably if going by that chart as well, a number one reason could also be of your incident if a secret was found on the internet somewhere, someone's using it and trying to figure out who owns this and where do I take this and what do I do with it and all of that as well. So there's a lot more complexity around just to what you called out, where was the problem? Now you're like, oh, I should probably just quit my job and walk away.
Exactly,
The problem is too big. Are there any interesting breaches that you would have heard? And not that I'm not trying to have like a fear, uncertainty, doubt kind of a mindset, but more from a understanding that, hey, this has happened. It's not just we don't really have anything important.
Yeah. So there's like so many to look at. There's one interesting one that happened last year, and it's interesting because it illustrates a few things. It happened with Toyota, car manufacturer.
Yeah.
They have a product called T-Connect. Mobile application connects to your car.
Yeah.
Important.
Yeah.
Toyota had consultants working on this as well, contractors working on the code. It wasn't Toyota, it was actually a contractor that accidentally made code public. Inside that code was the access credentials, database credentials to all of the users using T-Connect, all of their information. Now that was public for many years before a security researcher found it and let them know. But who knows who found that secret beforehand. But in terms of impact, is much worse than that. That's an interesting one because Toyota didn't really do anything wrong.
Yeah.
It was a contractor that was disconnected supply chain issues, right? But if like another recent one, Uber, they had a worst case scenario where credentials were sold on the dark web that were for an employee for the VPN service.
Yeah, okay.
They had MFA. MFA was bypassed just by spamming it. So the employees whose credentials were lost accepted the MFA request. Hackers made it onto the network. The first thing they did, like we talked about, they tried to find more secrets.
Yeah.
There was a PowerShell script. This PowerShell script was used for when a new employee started. So you started, I run this PowerShell script and it created accounts for you on everything that you needed. Inside that PowerShell script was the worst credentials that you could ever leak. It was for the PAM system, the Privileged Access Management System.
Yep.
Basically the keys to the kingdom. So what do the attackers do? The attackers created accounts for themselves in every single one of Uber's services. Worst case scenario, and this is a secret that's in an internal network, so this is secrets. We're talking about public a lot, but internally as well. And just like very quickly, there's ones like CodeCov. It's a supply chain tool. They leaked a secret was discovered.
Yep.
Application turned malicious. Attackers were then able to access the private source code of CodeCov's customers. So like all of this, like secrets are just kind of everywhere. And like they're always used in attacks because maybe not as initial access, but definitely to elevate privileges, to move laterally, to persist the attack. And if you don't have good alerting, if you're correctly authenticated, how do you even know that an attack is there, right? They're using the systems in a way that they've designed to it. So alarm bells aren't even going off.
Fair enough. Considering we have pulled down the why, how about you raise it up? Is there a funny story to the whole secret thing as well? Like, let's just raise the bar back up again to be happy again.
Well, yeah.
Before people get depressed, like, wow, it's like, that's a lot of secrets, Mackenzie. You're like, feeling so depressed right now. But is there a funny story as well?
Yes, there's a funny story, but I don't know if they raised it. I think they might bring down the vibe again. One of the funniest things that I have found in doing this State of Secrets Sprawl Report is that every year we find secrets in the weirdest of places.
Yeah.
And so we found 500 commits where their commit message was the private GitHub access token. So this is essentially like I'm sending an email and the subject line of my email is my password. So obviously some people have been confused of how Git works or authenticates, and the message they think is maybe a header and they're passing a credential through the commit message, but we find secrets everywhere. That's a story that
that did not bring it up. It took it further down. Like every security person listening is going, wait, so it gets worse. It's not just that it's everywhere, but now I have to look out for people sending emails as well.
Yeah.
Because I think that's a good point as well. Because I think, was it Verizon, the report that they did for data breach, they had, I think number 1 or number 2 reason was accidental information. Like, so I'm typing in Mackenzie Jackson, but I know another Mackenzie, and you know how it does like tries an autofill?
Yeah.
And people just like, well, oh, well, I guess it's Mackenzie, but it's not Mackenzie Jackson. It's like Mackenzie, I don't know, something else.
Yeah.
And Johnson or something, I guess. I'll just go with that. And without even realizing it, you send like sensitive information to another person who just happens to be one Mackenzie that you knew from ages ago with at Gmail address, and like, oh, next thing you know, they're public. And I think that to me was quite surprising, where even no matter how hard a lot of people have tried, secret sprawl is going to happen. So I guess where I'm going with this is like, where do people start?
The first thing, the important thing to know is identify where your secrets are, right? So,
or should be at least.
It should be, right? You know, like, so you've got your secrets manager. So get a good secrets manager, and one that is actually going to use. There's lots of great ones out there, but some of them are too heavy for what you need. You got 10 developers. You don't need HashiCorp Vault.
Yeah.
You can have it. It's great, but maybe don't. And then identify where they've leaked, right? Look in your systems, understand where your code's leaking, because that's going to give you an idea of how they're leaking.
Yeah.
What repositories, what teams maybe need more training and more understanding about secrets.
Yeah.
And then once you have visibility over where your secrets are, start putting in some gates to block it. Git hooks, requests on your CI/CD pipelines. Make sure that you've found this pool of blood. Let's stop the bleeding. Whilst we're working on that as well. And so that's really the best way of trying to combat this situation.
You mentioned Git Hook a couple of times.
Yeah.
With security people trying to do this, listening on the other side or watching on the other side, how hard is implementing Git Hook without, say, if you were a developer, do I have to have access to your laptop to do Git Hook?
I don't like this question. Git hooks are fantastic. They're probably the most effective way of stopping something early, but they're problematic. They're part of the solution. You also need to have scanning on the infrastructure. The reason why is that Git hooks are configured locally. So yes, you need to set them up on the developer's machine. There are ways that you can kind of automate this, but they need some kind of,
trigger.
Trigger. The other thing is that hooks can be bypassed. You put a -n at the end of your commit and the hook will still run. So they're not foolproof.
Right.
What is foolproof is scanning in real time your infrastructure. Knowing when secrets leak in your Git repositories, knowing where they end up. So that's kind of like, that's the most important part, getting this visibility and knowing where your threats are. And then there's things that you can do to prevent the bleedings, but you can't rely on them.
That's right.
Yeah.
And maybe education could be one way, but still.
Education is great.
Yeah. I think it definitely doesn't solve the problem. But there are tools, I guess where I'm going with this, there are tools available which could be native to a developer platform. Which security teams can use to enable themselves from finding secrets and doing all of that as well.
Absolutely. There's lots of tools that you can use. So there's open source secrets detections. They give great coverage. Some of the problems are when you get too big, you're going to have a lot of noise. So the problem comes reducing that noise. But you know what? Like, if that's where you start, that's where you start. Like, start with an open source solution. It doesn't require you to talk to the accounting department. Like, you can get started, right? So this is the main thing. And that may seem weird coming from someone that works from a vendor, but at the end of the day, like, just to start somewhere. When you get big enough, you're going to have issues with remediation and stuff, and then look what's available on the market. But start at open source, keep it simple, because at least then you're going to be more aware of the problem. I think that's the key takeaway.
My second last question, because I find that a lot of conversation security are harder to sell to people to believe in the idea that, hey, you gave a couple of examples for how breaches have actually been caused by secrets. But the bigger challenge over here also becomes that making people realize it's important to care about secrets. And it's not just, hey, I'm going to password manager and data sprawl is not a good thing. Have you found some insights over there as well, where what can people use as a tool or mechanism to highlight to, say, a broader non-security audience as well, that, hey, we should care about secrets, and without using the whole, I guess, which is important to know that there's something happened. But have you found any other way of identifying it, or apart from just finding, hey, there's a secret, you probably should look at that, like in the crown jewel somewhere, I guess?
Absolutely. If you're struggling to convince management that you need to invest in like some security tools, then like start open source and prove the problem. But there's other areas too, like vendors will often give you a report of the problem. So one thing that like GitGuardian can do is that we scan all public information. We can let you know how many secrets have been leaked from your employees. Like things like that. So like show you that this is actually not a hypothetical issue. And if we can't find any, great, you don't need the tool.
That's
like,
right.
You're good.
You're good.
Right? I mean, I shouldn't say that, but that really illustrates the problem. And I think once anyone understands how big of the problem is in internal infrastructure, because secrets just leak. They just do.
Yeah.
right? And secrets managers are important and they help solve the problem, but the secrets are going to leak.
Yeah.
And so once you start scanning your infrastructure and just simple, like your Git repositories are a good place to start, you're going to find that you have a problem.
Yeah.
It's a good place to start, And last year we saw so many companies have their private source code leaked, like Microsoft, NVIDIA, Samsung, to name a few.
Yeah.
They all had secrets in the source code. Big companies like that with great security posture, like I'm not picking on them. If they have secrets in their source code, everyone will.
Yeah. Right. So where can people learn about it? Because I think that's kind of like my question, because I also feel like there's clearly an education piece missing in the fact that secrets are not just username password.
Yeah.
They're a lot more than that. And people have to go down the journey of identifying, hey, what kind of secrets do I have?
Yeah.
Which are more than my username password. Is there like resources for these that you normally point people to?
Yeah, for sure. I mean, we try and create a lot of resources, like the State of Secrets Sprawl Report. It's great. We have a blog where it has, endless information about detecting secrets and areas like that. But in terms of like general resources, I would say like the OWASP top 10, they talk endlessly about secrets. There's the API and secrets cheat sheet from OWASP.
Okay.
Like you look at like how do you actually manage and handle these secrets? That's a great resource. So there's areas like that where there's lots going on. There's a really cool project called Wrong Secrets by OWASP again. And it's an application where it gives you challenges to try and find secrets in the application. Again, it's progressively harder, but it lets you know actually like, oh my God, like I can have a secret in my running application and I didn't even know.
Yeah.
How can you find that? So there's some great educational tools if you want to learn out more from the GitGuardian website, but on OWASP and also on lots of other resources as well.
Awesome. Well, that was all the questions I had. Where can people find you on socials to know more about secrets? And maybe you can lower the mic even more.
I should have. Ah, damn it. Yes, I'm everywhere on social media at Advocate Mac. So on LinkedIn, on Twitter.
Advocate Mac.
Advocate, yeah.
Fair enough. Awesome. I'll put that link in the show notes as well. Thank you so much for watching, everyone.
Yeah.
Thank you, Mackenzie. And
Thanks.
we'll see you next episode. See ya. Peace.
When you're developing an app, security might be treated as an afterthought. With functionality requirements and tight deadlines, it's easy to accidentally write vulnerable code or use a vulnerable dependency. But Sneak can help you secure your code in real time, so you don't need to slow down to build securely. Develop fast, stay secure. Good developer. Sneak.